So we have started with the next topic that is known as the demand side management. So we will continue with the second topic of our unit number 5. The first section of this is demand side management. So let us first understand what exactly is the requirement for the load management, and then we will see what exactly is the demand side management. So as in the last lecture we have seen that whenever there will be requirement of the electricity, like whenever there will be population increase, whenever there will be increase in the industries, and whenever all these things increase, we require power, right? And whenever we require power, every time it's not possible for us to install new power plants. And in order to meet all this shortfall in the capacity, there has to be some management in the load side as well. Like you all know peak off peak period. These are all practiced nowadays. Here in this point, you will see TOD tariff. So basically, TOD tariff means time of day tariff. So based on the timing of the day on a 24-hour scale and the usage of the electricity, the consumer is charged accordingly, right? So that's why some type of management is required at the load end as well, so that we can avoid the addition of the capacity. Why so? Because whenever we think of addition of capacity, then this addition will require additional um, natural resources. Like if it is a coal based power plant, our natural resources will be used at a rapid pace. And in this with this rapid pace, if we use it, the reserves which are available with us, this will be exhausted very rapidly. Then we will have to think of the alternate energy, and then one day or the other day we will have to think of the alternate energy sources. So that's why the need for electrical load management, first point you will see shortfall in the capacity to meet demand. So whenever we have seen about the supply and the demand position, so demand will be always more, and supply will be at par with that, or sometimes it will be less than the uh, demand, right? So every time we cannot like bridge the gap. What do we mean by bridge the gap? Like if the demand is say 100 megawatt, then supply cannot be 100 megawatt at all the time for developing nations. This will not be the case in case of the developed nations. Like the developed nations like United States of America, United Kingdom, Canada, all these are the developed nations. So, developed nations, the gap is very less, or sometimes it's equal. Like the demand and the supply both are in equilibrium position. But the countries which are in developing stage or underdeveloped stage, in that there will be always a gap between the supply and the demand. And in order to minimize this particular gap, we have to think of the electrical load management. Next point is capacity addition is a costly and a long time prospect. So we have seen that the gestation period, that is the time which is required in order to install a new power plant, which we also sometimes call as the greenfield power projects. So the time required to install a new power project is very large. Like if we take the case of a thermal power plant, it takes about 3 to 5 years to complete the complete installation of the thermal power projects. Similarly, if we take the case of nuclear based power projects, again it takes almost the same time. So that's why capacity addition is a costly affair. At the same time, it takes a long time to complete the installation process. Next is better load management at user end helps to minimize the peak demand on the utility infrastructure. So, what is the meaning of this is whenever we think of the load management, and at the peak load, if we are using more electrical energy, then we will have to pay more amount in our electricity bills. So if we can optimize this particular usage, then probably we will be able to uh, make better use of the electrical energy, and maybe we will not have to pay at a huge amount to our utilities. Next is better utilization of the power plant capacity. So what do we mean by better utilization of the power plant capacity is, um, whenever the plant load factor, if we are talking about, then in case of the plant load factor, what happens is plant load factor has to be at a higher end. Then only the load factor will be optimized, and there will be a better utilization of the power plant capacity. uh, like if say we have installed capacity of the plant is say 100 megawatt, and the load connected to that particular plant is say very less, that is about 60 megawatt or 70 megawatt. So what that power plant will do of the excess generation? So that's why in order to better utilize the power plant capacity, we have to optimize the load as well. So that's why there is the need for the electrical load management. Then we have seen the TOD tariff penalties on exceeding allowed maximum demand, night concessions, etc. by utilities. Like if you are exceeding your maximum demand, we have many times seen our electricity bill. In the electricity bill, we have our contract demand. So if you exceed the contract demand, like if the contract demand is there are two types of consumer, LT consumer and HT consumer. In case of the LT consumers, the contract demand is up to 5 kilowatt or 2 kilowatts, or maybe less than that also. But in case of the HT consumers, this is very high, and whenever this demand is exceeded by the HT consumers, then what will happen? They have to pay the penalties to the utilities from where they are purchasing the electrical energy. So, TOD tariff penalties on exceeding allowed maximum demand, night concessions, etc., by the utilities. This also allows us for the need for the electrical load management. Then next point is demand charges constitute considerable portion of the electricity bill. We have already seen some numericals related to this, and we have seen that how the uh, changes in the demand changes the electricity bill as well. We have already seen few numericals associated with this, and we have seen that how by improving the power factor, this demand changes, and the demand charges which the consumer has to pay, this also changes. So that's why there is a need for the integrated load management to effectively control the maximum demand. So we have to effectively control our maximum demand. Then only we will be able to make use of the our power plant in a better possible way, and the consumer will be able to pay the optimum amount of the amount in case of the tariff. So this is all about the need for the electrical load management. So is it clear, everyone? Have you all understood about the electrical load management? Please reply first. Have you all understood why we require the electrical load management? Because every time it's not possible for us to like increase the capacity of the generation, and every time it's not actually advisable also that every time we install new power projects, because addition of the new power projects will be utilization of the natural resources very rapidly, right? So that's why we have to think in that perspective also, that whenever we add new power plants, then the natural resources will be exhausted at a very rapid pace. So that's why we have to think of that part also. So with that we have understood what is the need for the electrical load management. Now let us move on and see what are the various steps which are involved in the electrical load management or demand side management. So this is basically called as the demand side management. So one by one we will see what are the various steps involved in the maximum demand control. So the first point is load curve generation. We will see in detail what are all these points. Then rescheduling of loads, then storage of products, then shedding of non-essential loads, then operation of captive generation, and reactive power compensation. So these are the various steps which are involved in the demand side management. Let us see one by one. First, we will start with the load curve generation. So, in case of the load curve generation, what happens is we plot the load curve, like we will take 24 hours. See, we will start from 7 a.m. in the morning and we will end up with 6 a.m. in the morning. So, this is the complete load curve of the 24 hours. And here you will come to know that there are some peaks, there are some falls. So, with the help of this curve, we will be able to know the load curve pattern of the particular consumer, and based on that, we will be able to actually decide what is the pattern of the curve for the particular consumer, and based on that, we will be able to optimize our utilization. Next is rescheduling of loads. So when we talk about the rescheduling of loads, to minimize simultaneous maximum demand, rescheduling of large electric loads and equipment operations in different shifts can be planned and implemented. To prepare an operation flow chart and a process chart, analyze the process chart to reschedule the operations and running equipments, increase load factor to reduce the maximum demand. So these are all the points which will help you for rescheduling of load. Like if I know that the utility is charging a high amount at say from 11 a.m. to 2 p.m. So, if at all some loads can be rescheduled, like whatever load I was running from 11 a.m. to 2 p.m., I can reschedule it after 2 p.m. Right? So, in that way, I will reduce my electricity bill. So, that is what we exactly mean by the rescheduling of load. So, with the help of rescheduling of load, we can minimize the simultaneous maximum demand, and these loads can be shifted from one part of the day to the other part. Wherever we can shift these loads accordingly. How we can do this? We can prepare an operation flow chart and a process chart. So I can make a operation flow chart and a process chart. Based on that, what I can do, I can think of that in which part of the day which load should be utilized, so that there will be optimization of the maximum demand. Then analyze the process chart to reschedule the operations and running equipments. Similarly, increase the load factor to reduce the maximum demand. So these are some of the points related to the rescheduling of loads. Next, let us see storage of products in process, material process utilities like refrigeration. So this is something which is related to the industrial application. So reduce the maximum demand by building up storage capacity of products during off-peak hours. So off-peak hours means the hours in which the utility charges less amount of the usage. So at that time, what we can do, we can build up the storage capacity of products, so that like refrigeration. So in case of refrigeration, if the products are stored in the refrigeration chamber, in the part of the day when the electricity bill is less charged by the utilities, So that will help us to reduce our consumption. Then off-peak hours operations also help to save energy due to favorable conditions such as lower ambient temperatures. So the lower ambient temperatures are there in the off-peak hours. So it helps to save the energy due to the favorable conditions. Then shedding of non-essential loads. So you all are already aware of the load shedding. Some years back, not now, because now we are in a better position in terms of the supply and demand level. So now there is a very few a percentage of the gap between the supply and the demand. But few years back, when the demand was very high, but the supply was very low. In that case, there used to be load shedding of say 2 hours, 3 hours. Our electricity suppliers used to publish it in the newspapers, and by that way, we used to come to know that in our area the power is going to be cut for from 4 p.m. to 6 p.m. say, right? Have you all gone through this situation anytime? Say few years back, 2 3 years or 4 years back, they used to give notice in the newspapers that in your area the power shedding will be from this period to this period. So anyone who has gone through this period few years back, not now, particularly during the summer season, because in summer season, due to the unavailability of the waters, or the water bodies used to get dry, and because of that, what used to happen, the power plants were not able to get the water supply, and few units of the power plant has to be shut down. And as the generation will be less, we will not get the supply position, and that's why we have to the utilities have to plan for the load shedding. No one? प्रियंका, कल्याणी, कंचन, किसी के भी घर में कभी भी लोड शेडिंग नहीं हुआ? लोड शेडिंग का मीनिंग समझ में आ रहा है ना सभी को? व्हाट डू वी मीन बाय लोड शेडिंग? Yes, that's what
Why,
I was
sir?
asking. That Yes, that's what I was asking. कि load shedding, whenever the utilities inform us कि इतने बजे से इतने बजे तक लोड शेडिंग होगा, है ना? तो वो तो यूटिलिटी ने आपको इन्फॉर्म किया, बट आपने अगर खुद से डिसाइड किया कि इतने बजे से इतने बजे तक मैं ये चीजें बंद करके रखूंगी, है ना? तो that will be called as the shedding of non-essential loads. Again, energy conservation doesn't tells us that कि रिक्वायरमेंट है फिर भी आप सारी चीजें बंद करके बैठ जाओ, ऐसा नहीं है, राइट? वी आर टॉकिंग अबाउट शेडिंग ऑफ नॉन इसेंशियल लोड्स, मतलब ऐसे लोड्स जो हमारे लिए इसेंशियल नहीं है. सो शेडिंग ऑफ टेम्पररीली सम नॉन इसेंशियल लोड्स कैन हेल्प टू रिड्यूस मैक्सिमम डिमांड, and install direct demand monitoring system which will switch off non-essential loads when present demand is reached. So these are some of the principles of the shedding of non-essential load. Then operation of captive generation and diesel generation sets. Captive generations, मैंने आप लोगों को बताया था what is the meaning of captive generation. Captive generation का meaning है, for example, if Indorama is having a huge textile mills, and if they will buy the electricity from MSEDCL, they will have to pay a huge amount in the electricity bill itself. What will be the impact of this? The impact of this will be in the product. So whatever product they are manufacturing, that product will not be able to fetch higher amount in the market, and their profits will be reduced. So in that case, what they will do? They will have a captive power plant. Captive power plant means they will have their own power plant for their own application. So, operation of captive generation is one of the possible solution for the demand side management. So, whenever the demand reaches the peak value, it is advisable to connect the DG generator sets for some duration. Why? Because if you are exceeding the demand, the contract demand, let's say if the contract demand is say 100 kVA and your demand has reached its peak value, now beyond that peak value, that is 100 kVA, if it is exceeding to 110, 120 or 130, you will have to pay the excess, that is say a 10 kVA, 20 kVA or 30 kVA. This excess bill will be charged as a penalty by the utilities. So in that case, what you can do, you can have your own captive generation, or you can have your own diesel generator sets, and you can power on that, so that you can avoid the penalties which will be charged by the utilities. Next is reactive power management. So this we have already seen at a very detailed way. We have solved few numericals wherein we have calculated the kVAR rating. We have seen a specific formula related to that. The formula was kVAR is equal to kW multiplied by tan phi 1 minus tan phi 2, where phi 1 is the present power factor and phi 2 is the desired power factor, right? So by that way, installing the capacitor banks, we can maintain the optimum power factor. We can actually reduce the reactive power in the system, and we have microprocessor. There are microprocessor based capacitor banks which can on and off the capacitor bank whenever it is desired in the system. Like whenever your inductive load will be more in the system, naturally your power factor will be deteriorating, right? Your power factor will degrade whenever there will be more amount of inductive loads in your system. So whenever such type of things will happen, if you have a microprocessor based capacitor bank, you can on and off as per the requirement of the system. In order to improve the power factor, if it's already improved, you can switch off the capacitor bank. If it's degrading, you can switch on the capacitor bank in order to optimize the maximum demand. So, is it clear, everyone? The first part, that is demand side management. These are few points which helps us to know what are the various ways of the demand side management. So you can note down all these points if you want, because all these points can be used to elaborate your answers in the questions that may be asked in the university question papers, or in for your further process also. If you want to know all these points, you can have these points available with you. Shall we move ahead? Next part is selection of the motors. Is it clear, everyone? Shall we move ahead? Okay. So next part is about the energy conservation in the motor. So as you all know that motor forms the large part of any system. If you will go to any factory, any plant, the majority of the electrical component which is installed is the electrical motors. So that's why the energy conservation in motors is very important for us. We should know what are the various ways for the conservation of the electrical energy in the motor. So for that, first we should know what are the parameters which attribute to the efficiency of the electricity used by the AC induction motors. So AC induction motors form the large part in any industry, whether it is steel plant, whether it is paper and pulp industry, whether it is cement plant or any other type of plant. Wherever you will go, you will find this AC induction motors in a very large quantity. So let us see what are the parameters which attribute this efficiency of the motor. So the first part is the efficiency of the motor, and second part is the power factor. So efficiency of the motor, like if we want to define, it will be the ratio of the mechanical energy delivered at the rotating shaft to the electrical energy input at its terminal. So, in a very basic term or basic terminology, we can state the efficiency of motor as is nothing but the ratio of the mechanical energy delivered at the rotating shaft to the electrical energy input at its terminal. So, what should be our aim? Our aim should be to reduce the electrical energy input at the terminal. If we can reduce this electrical energy input at the terminal for a given RPM required for the mechanical energy at the rotating shaft, then we can increase the efficiency at a very optimized way. So there are various ways by which we can reduce the electrical energy input at the terminals. We will see in the coming part. Next is the power factor. So like other inductive loads, power factor is less than 1 in case of the motor, and the total current drawn needed to deliver the same real power is higher than for a load characterized by a higher power factor. So we all know that motor is an inductive load. So with the property of this inductance, the power factor will be always at a lower end. So the same amount in order to have the same amount of the work to be done, the total real power or the active power which will be required will be at a higher end if the power factor deteriorates. That's why these are the two very important attributes in case of the electricity which is used by the AC induction motors, and we have to be very careful for in case of these two terms, that is the efficiency of the motor and the power factor of the motor. So next we will see what are the parameters which influence the selection of the motor. Like if you have a textile industry, if you have a cement industry, or for any other applications, so what are the parameters which influence the selection of the motor? We will also see a video related to this. First we will know what are the parameters that influence the selection of the motor, right? So the parameters which influence the selection of the motor, one by one we will see. Torque requirement, load characteristics, ambient operating conditions, reliability, inventory, price, efficiency. So these are all the parameters which influence the selection of the motor. So one by one we will see in detail. Torque requirements or the load characteristics. So, what is the requirement of the torque for your system? Uh, Whether it is at a very higher end, lower end, what will be the case of the load characteristics? All these things we have to be careful, and we have to know it before we can actually select a particular motor for the any particular thing, right? So if we select a motor which is actually not required for us, uh, and if we don't want to install a high end motor in terms of HP, let's say depending on the torque requirement and the load characteristic requirement, let's say 7.5 HP motor is the best suited motor. But instead of 7.5 HP, if we go for a lower HP motor, like if say we will select a 5 HP motor, then the torque requirement is compromised. At the same time, load characteristics will also change. So that's why it's not advisable to go for a lower end motor. At the same time, it's not advisable to go for a higher end as well. Like if 7.5 HP motor is able to complete your torque requirement or the load characteristic, but you are going for a 10 HP motor, so you are over budgeting your system. Your price of the system will increase, and if the price of the system increases, naturally the impact will be on the product which the plant is manufacturing, right? So these are the some of the points which have to be considered while selecting the motor correct size of the motor for a particular application. Whatever applications you are going to run, the selection has to be optimized. If the selection is not optimized, then the entire things will fall into the budgetary part of the system, or the technical specifications of the system. Like if the torque requirement is mismatching, the ultimate product that you are manufacturing from that particular plant will suffer, and the product will not be of that quality which will be required in that particular system. So this is some of the points which are required for the selection of the motor. Next, quickly we will see what is the constructional aspects of energy efficient motor as compared with the standard motor. So we will compare an energy efficient motor with a standard motor. So, what is the standard motor, or standard of the motors are already defined by the various authorities. There are various standards, like we have IS, that is Indian Standards, BIS, that is Bureau of Indian Standards. Then there are international standards as well. Um, like we have IEC. There are various standards which are already defined for a standard motor, as well as the new terminology which is coming up is the energy efficient motor. So let us understand what are the constructional aspects with which the energy efficient motor differs from a standard motor. So in case of an energy efficient motor, there will be higher quality, low loss laminations for the magnetic circuit. Then it will have more and better quality copper in the winding. This we are talking about the energy efficient motor, and we are comparing it with a standard motor. So an energy efficient motor will always be of higher quality, low loss laminations for the magnetic circuit. It will be more, and it will have more and better quality copper in the windings. It will have better quality insulation, optimized air gap between the rotor and the stator, so that there will be less losses, then reduced fan losses, and then closer matching tolerances. And of course, in the red portion, you will see a greater core length. So these are all the attributes which will be having with the constructional aspects of the energy efficient motors as compared to the standard motors. Now we will watch a video, and we will have a better insight of the energy efficient motors, or how a motor is selected based on the applications which is to be run. Uh, do you want to note all these points, everyone? Or you can take a snapshot of this and you can have it afterwards. Shall I wait for some time so that you write all these points and then we will view the video? Or shall we play the video? Please reply first. Okay, so you can take a snapshot of this. We will watch the video quickly. There is some error in the video. this is playing. Just a minute, I will turn on the sound.
In this module, we will continue to explore the 4 stages of selecting a motor by looking at the next 2 factors in the equation: infrastructure and standards. Network voltage and frequency vary around the world. Also, industries and applications may require voltages that are unrelated to the country where the motor is used or purchased. The ability of the local electrical network to support the application is of particular importance when starting the motor. For fixed-speed motors, an excessively long starting period will cause harmful temperature rises, and the high currents can cause electromechanical stress. The starting time is a function of load torque, inertia, and motor torque. Between starting speed and nominal speed, it must be ensured that even under unfavorable conditions, such as low voltage on motor terminals, the motor torque is always sufficiently high to cope with the highest possible load torque. Electric motors produce a lot of starting torque and can generally cope with the long, such as a fan or a pump starting with the valve open, where the impeller has to push against the full body of liquid straight away. Electrical supply current, so care must be taken to ensure that the local infrastructure can support these current peaks. Often, network restrictions on starting current will influence the specification of large motors. The growing practice of using smaller induction motors with variable speed drives is increasing the amount of reactive power taken from the network. This is something to consider when selecting the motor, since using